Consider a relation R which is defined from the set A to another set B as the ordered pair x comma y belonging to the relation R if and only if x is relatively prime to y. We need to express R as a set of ordered pairs, and additionally we need to determine its domain and range. Okay, let us begin. So first, let us begin by taking a note of the given set A and B. So it's given here that the set A contains 4 elements, the elements being 2, 3, 4, and 5. And then we have another set B. B contains the elements 3, 6, 7, and 10. Okay. And then we have the relation R. The relation R is the set containing the ordered pairs x comma y such that. So here we have to consider x to be belonging to the first set A, because it's clearly mentioned here that R is defined from set A to set B. In other words, we have here is a Cartesian product between the set A and B. So here x is going to correspond to the set A and the element y is going to correspond to the set B. And we have a relationship between x and y. So x is relatively prime to y. Prime to y. So what does it mean when we say that x is relatively prime to y? This simply means, that means if we take the greatest common divisor of the two numbers x and y, it must be equals to 1 only and nothing else. There should not be any other factors other than 1. So what we'll do, we will have to form the ordered pair. So before forming the ordered pair, let's try to find out the specific values of x and y such that x is relatively prime to y. For instance, from the first set A, if we pick up x to be equals to 2, next, then what values of y can we pick up from the set B? So let's say if we pick up y to be equals to 3, then what is the greatest common divisor of the two numbers, 2 and 3? Yes, that's equals to 1, which means that 2 and 3 are relative primes. In other words, what we can show, 2 is related to 3. Fine. Next, what are the possibilities? So if we consider x to be equals to 2, so can we pick y equals to 6? No, y cannot be equals to 6. That's because the greatest common divisor of 2 and 6, that's going to be equal to 2. Now, since we have a number which is not equals to 1, so clearly we can say that the number 2 is not going to be related to 6. 2 and 6 are not relative prime. Next, if we choose x to be equals to 2 and then we choose y to be equals to 7, then definitely the greatest common divisor of 2 and 7, that's going to be equals to only 1, meaning 2 is going to be related to 7. So we cannot relate 2 and 10 because then we will again have a greatest common divisor of 2. Fine. So that means we have 2 are 3 and 2 are 7. Next, if we pick up x to be equals to 3, then what value of y can we pick up from B? Can we pick up 3? No, we cannot pick up 3 because then the greatest common divisor will become equals to 3. We cannot pick up 6, however, we can pick up 7. So we can pick up y to be equals to 7 such that 3 is related to 7. The greatest common divisor of 3 and 7 is only going to be equals to 1. Next, can we pick up 3 and 10? Definitely, we can also pick up 3 and 10. 3 or 10 is also going to be a possibility. Okay, next, come to number 4. So if we pick up 4, what other element? If we pick up 4 from the set A, we have to pick up some other element from B such that the 4 and that number picked up from B are relative prime. So we can pick up 3 from the set Y. So 4 or 3 means 4 is related to 3, meaning 4 and 3 are relative prime to each other. Then we can pick up 4 or 7, meaning we are picking 4 and 7 because the relative prime between 4 and 7 is going to be the greatest common divisor between 4 and 7 is going to be 1, meaning 4 and 7 are relative prime of each other. Next, 4 and 10 cannot be picked up. Next, what we'll do, we'll pick up the element 5 from the set A, and we're going to find its relation with the element in set B. So we can pick up 5 or 3 such that 5 and 3 are relative prime. Then we can pick up 5 and 6. So 5 or 6 are going to be relative prime. We can also pick up 5 and 7. So 5 or 7 are relative primes. Okay, fine. So 5 and 10, that's not going to work because the greatest common divisor is going to be 5. So we have found out 1, 2, 3, 4, 5, 6, 7, 8, 9, total of 9 relations. So let's now define the ordered pair for the set R or for the relation R. So 2R3 can be converted into an ordered pair as 2, 3. Make sure that the element to the left of R becomes the first element of the ordered pair, and the element to the right of R, which is 3 here, becomes the second element in the ordered pair. Next we have 2R7, so we can rewrite it as 2, 7. 3R7 becomes 3, 7. Next we have 3R10, so 3, 10. Next we have 4, 3, followed by 4, 7. Next we have 5, 3. Then we have 5, 6. And we have 5, 7. So this is the relation R expressed in terms of its ordered pairs. Now that we have the relation R, we also need to find its domain and range. Okay, so let's try to first obtain the domain of the relation R. The domain of R is simply going to be the first element of each of the ordered pair. So here we have the element 2. So element 2 is repeating. We don't have to repeat that while writing the set. Then we have 3. Next we have 4, and then we have 5. So 2, 3, 4, and 5, these are going to be the domain of the relation R. Then what about the range? The range of the relation R, that is simply going to be the second element of each of the ordered pair. So here we have 3, we have 7, we have 3, 7, then we have 10, then we have 10. So 3, 7 already we have mentioned, 3, 6. So 6 is also present. So 3, 7, 10, and 6, these are going to be the range of the relation R, such that the first element in each of the ordered pair is relative prime to the element in the second element in the ordered pair.